Alrighty, now we're going to take a look at types of addresses within IPv6, okay? All right, and we have a little table here to help us, all right? So we have the Unicast address, and we know what Unicast addresses are, but we really need to read the definition. It's going to a particular individual. The packet is directly being sent to one end device, okay? A global unicast address. That's why you see here 2000:/3, right? 2000 to 2001. I believe it goes all the way to 2003, honestly. When you see that number at the beginning, that's a global unicast address, meaning a public IP address. All right. Link local. Woo! Replacement for the APIPA. Replacement for the APIPA. Okay. Now you've seen this part, right? Okay. You want to take a look at that? You're going to have these PowerPoints anyway, but replacement for the APIPA. Okay. No more broadcast. No more broadcast. These link local addresses will be on every NIC card, every interface on the router. Whatever device has some sort of internetworking card, whatever, NIC card, it's going to be there, whether it's DHCP or not, because you can create a network with this, all right, with a link local. All right, so just be aware of that. Just be aware of that. There's a lot to the link local address, not just that, because now we have this discovery, okay, with IPv6. That's why there is no ARP, okay? But again, I'm trying to get ahead of myself, because that's with ICMP, all right? Because there is a discovery portion of it, and there's router advertisements and router solicitations and all these things, which also creates a security hole, but we won't go off on a tangent. We have unique local addresses. They can be here. It says FC00, but it also can be FD as well. All right. Cisco says it in their book. FD can be also considered a unique local. What's a unique local? Here we have a global. Here's a unique. Well, that's local. That's private. It's like a private IPv4. There's like a private public IPv4. Okay. Multicast. Anytime you see anything with FF, it's a multicast address. And what I'm most concerned with multicast addresses is that you know your routing protocols, RIP, EIGRP, and OSPF. What multicast address do they use? And I will give them to you, okay? So you know what they are, because that is what you need to know. That is what you need to know. But again, if you see FF, multicast, and the new one, which is Anycast address, and let's read this. Anycast packets is delivered to only one device, the one closest to it based on the routing protocol used. That's why it is called the one to nearest. Also, you can use any single address to more than one host. I told you this. The Anycast address is it's taken from the unique local address range. But at the end of it, you put Anycast. So based on your routing protocol, analogy, where I live, I need to go to the supermarket. I go to a particular one, something we hear on TV all the time, Publix or whatever, right? But there's like 4 different Publixes in my area. Well, my router, which is my brain, takes in these variables, right? And says, well, I want to go to Publix, that's one address. But which way do I go? Well, it's 3 o'clock in the afternoon. I know school's out, so there's a lot of school traffic. So which street should I take? Which one will be nearest to me based on a lot of different characteristics, a lot of variables that I take in, and then I make my decision. And that's the same thing that happens with an Anycast address. If you're looking for a particular type of service, you're going to go ahead and do that. Okay, you're going to see, okay, you're looking for this service. All right, it exists on many routers or many end devices, that same address, but which is the one nearest to me based on RIP, based on EIGRP, based on OSPF? Because remember, RIP, hop counts. EIGRP uses bandwidth and delay metrics, and OSPF uses cost. So depending on the quickest way, that's the way I'm going to go. All right, so that's what the Anycast address does. That's one of the newest. That's the newest implementation with IPv6, obviously. All right, that we have now, which is great, because in IPv6, not only can you assign one address of each on an interface, With IPv4, you can only assign one address. You could assign two addresses to an interface as a secondary IP address, but that never went too well. So you can only assign one address per interface. Here, you can assign multiple IPv6 addresses. You can get away in IPv4. You don't even have to put no IP address. You can just override the IP address that's there. Not so with IPv6. With IPv6, if there's an address in an interface that you don't want, you better take that address out. No IPv6 address, blah, 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 and take that out and then put in the new one. Because if not, it's just going to put another one in there and another one in there and another one in there. That's the only thing with IPv6. It allows for multiple IP addresses. It's good, but it's also bad because we forget, and we're so used to IPv4 that we do forget to take it out. All right, so these are the types of IPv6 addresses that we will be working with, all right, when we go out there in the real world. And some of these, obviously, in our lab, we'll get to see them. See you in the next.